Right, so last time we were testing two variable equations, graphs for symmetry, right? We were looking at x-axis symmetry, y-axis symmetry, origin symmetry. We had done one example. We want to do a few more examples for you here so you get a little more, so you can see a bit more important, right? So here, this first problem, we want to determine if the graph of the equation has x-axis symmetry, y-axis symmetry, or origin symmetry. So we want to test, right? We want to test for all three types. So what are we going to test for first? I guess we'll test for what? X-axis symmetry. You remember how to do that? You're going to take your purple, replace y with negative y, right? That's how you test for y-axis symmetry. Replace y with negative y in the equation. Okay, so I'm going to write down my equation. I have what? X equals blank cubed minus blank. So we're replacing the y's with negative y's. So in place of the first blank, I'm going to put a minus y. And in place of the second blank, I'm going to put a minus y. I'm going to simplify this. So I got what? X equals, so here we have an odd power, right? An odd power outside of that parenthesis. So we're allowed to extract the negative, right? We can have a minus y cubed. Minus y cubed. We basically pull the negative out of the parentheses. We got minus y cubed. And the double negative here is going to make a plus y. So we got x is equal to minus y cubed plus y. So the question is that the same, is that equation where we replace y with negative y, is that the same as the original equation, x equals y cubed minus y? No, it's completely different, right? So this is not the same. So we're just going to say no x-axis symmetry here. No x-axis symmetry. Now on to testing for what's called y-axis symmetry. Do that one in red. Get our purple and say we're going to replace the x with negative x, right? Replace x with negative x and see if it turns out to be the same as the original equation. Okay, so here I'm going to replace x with negative x. So I got a blank equals y cubed minus y. And in place of that x, we're going to put a purple negative x. So when you simplify that, you literally just have what? Negative x equals y cubed minus y. Okay, negative x equals y cubed minus y. Is that the same as the original equation, x equals y cubed minus y? No, it's completely different. Right, you have a negative on the left side in this new equation. In the original equation, you had a positive on the left side. So this is a no y-axis symmetry. All right, so we got one more type of symmetry to test for here. What is it? We got to test for, remember, origin symmetry. It's going to go green. So you have to take your original equation and replace x with negative x and y with negative y. So let's see, what was our original equation? Let's see if we can scroll and find it. There it was. X equals y cubed minus y. All right, so let's make a template. Blank equals blank cubed minus blank. Now that should all be in green, right? Blank equals blank cubed minus blank. So in place of those blanks, so the first blank on the left originally had an x. We're going to replace that with a negative x. And the two blanks on the right, they originally had y's. We're going to replace those with negative y's, right? And when you do that, you're going to have, let's simplify. First of all, we're going to have negative x on the left-hand side. On the right-hand side, you have a cube above that negative y, so you can extract the negative. Anytime you have an odd power, you can extract the negative from the parentheses. You're going to have minus y cubed. And the double negative there makes it plus y, right? So you have negative x equals minus y cubed plus y. So the big question, is that equation the same? Is that equation the same as the original equation? So is negative x equals negative y cubed plus y the same as the original equation? X equals y cubed minus y. Let me write that down. X equals y cubed minus y. That's the original. I'll put that in black. Original is right here to the side, so we don't lose track of it. X equals y cubed minus y. So the question is, are these the same? Are these two the same, these two equations? Negative x equals negative y cubed plus y, and x equals y cubed minus y. A lot of people are inclined to say, no, it turns out that these are actually the same equations. These are equivalent equations. They are the same. If you look at your green equation there, negative x equals negative y cubed plus y, and you multiply both sides, let's say by negative 1. So I multiply the left side by negative 1, and I multiply the right side by negative 1. What happens is, well, negative 1 times negative x gives me x. On the right side, if I distribute that negative 1 through, I'm going to get y cubed minus y. And that is exactly the original equation, so that's a check mark. So yes, there is origin symmetry. So sometimes you have to do that with origin symmetry, not all the time, but sometimes when you actually have origin symmetry, you have to multiply through by a negative 1 to guarantee that it looks the same as the original. So a little extra work sometimes. All right, another example. Let's do another example. Okay, this will be what? This will be number 3. Here we have the absolute value function of x minus y squared equals 0. Absolute value of x minus y squared equals 0. So that is a two-variable equation. We want to test for the 3 kinds of symmetry. Let's start off with X-axis symmetry test. We're going to do a replacement of y with negative y, replace. Y, it's not y, is it? Y with negative y, and see if we get the original equation. All right, so we're going blue. And what the absolute value of x minus a blank squared equals 0. That's our template. And in place of y, I'm going to put my negative y right here. Now, we want to simplify that, and you have to remember, well, how do you deal with the negative inside of the parentheses? Well, square, right, is an even power. Squares kill off negatives in parentheses, so you're just going to have a purple y, quantity squared, y squared equals 0. Now that equation, absolute value of x minus y squared equals 0, is the same as the original, so that is a yes on that. Yes, there is x-axis symmetry. All right, let's go to the y-axis symmetry test. So with the y-axis symmetry test, you're going to replace x with negative x. And let's see, let's make our template. We're going to write a, let's see, absolute value of blank minus y squared equals 0. So in place of the blank, rather than putting an x, we're going to put the minus x. Now the question you have to be able to answer here is, how does the absolute value affect the negative? Well, absolute values kill off negatives essentially, right? It doesn't matter if you put in a negative x or a positive x. Absolute values positifies anything. So this is the same thing as the absolute value of simply x. Yeah, so the absolute value is killing off that negative. So we have absolute value of negative x is the absolute value of x. So here we have absolute value of x minus y squared equals 0. And the question is that the same as the original equation? This is a yes. Another yes. We have y-axis symmetry here as well as x-axis symmetry. Okay, and now we have to test for the final type, the origin type. Origin symmetry in green. So remember, with origin symmetry, when you're testing for that, you're going to have to do a double replacement. You're going to replace x with negative x and y with negative y. And what was our equation? I totally forgot. Absolute value of x minus y squared. Okay, let's set up a template for that. Right, we're going to have what? The absolute value of blank minus blank squared equals, what was it again? Equals 0. I totally forgot the 0 there. Sorry. So in place of the x, we're going to put a negative x. So a negative x goes within the absolute value. And in place of the y, we're going to put a negative y. So a negative y goes in the parentheses where the square is. Now, we're going to apply the absolute value. We have to answer the question, what does the absolute value to the negative? It kills it off. So the absolute value of negative x is the same thing as the absolute value of positive x. And then the question is, okay, then you put a minus, green minus sign. Then the question is, what does that square do to the minus y in parentheses? Well, the square kills off the minus. So you're just left with a y, purple y, green square, and then equals 0. The absolute value of x minus y squared equals 0. Is that the same as the original? Question, is that the same as the original? Scroll, please. Well, what was the original? Absolute value of x minus y squared equals 0. Yeah, that's what we got. We have the original. Back to the original. So since we're back to the original equation, this is satisfying that kind of symmetry. So what? Yes, we have origin symmetry here. So it turns out that this equation, its graph has all three types of symmetry, as you can see here. We've tested for x-axis. Go on, scroll. We have x-axis, y-axis, and origin symmetry, all three types. Yep, so that happens. Let's do one more problem, just for practice sake. I'm going to make sure we have plenty of practice. This will be a number 4, I guess. Third one on this video. Continuing from the previous videos. Let's say we have what? X squared plus y to the 4th equals 81. So we're going to do all three types of testing. We're going to do the first of the x-axis test. And then we'll do the y-axis test. And then we'll do the origin test. Let's start first. Come on. Let's start first with the x-axis testing. Where we're going to replace y with negative y. And see if the new equation is the same as the original. Yep, so I'm going to set up a template. I'm going to write what? X squared plus blank to the fourth power equals 81. And instead of putting a y in that parentheses, I'm going to put a negative y as a replacement. And we're going to copy down the x squared. We're going to copy down the plus. The fourth power is an even power. That's going to kill off the negative inside the parentheses, so we're just going to have a purple y, and then raised to the blue fourth power equals 81. And this is the same as the original equation. So yes, there is x-axis symmetry. Now for y-axis symmetry, we're going to do a replacement with x with negative x. And let's write down our template in red. We're going to have a blank squared plus y to the fourth equals 81. And in place of that blank in the parentheses, we're going to put, instead of an x, a minus x. And now we want to simplify. Okay, what happens? What happens? So the square is going to kill off, since it's an even power, the negative in parentheses are just going to have an x, a purple x, and then that's going to be squared. Should be a red square, right? Plus y to the fourth equals 81. Hey, that's the same as the original, right? The same as the original. So you have a yes to this type of symmetry. Yes, y-axis symmetry. And for the final test, we're going to do a double replacement for origin. For origin, we're going to purple, replace x with negative x, and y with negative y, and the original equation. Let's see, what was the original equation? Come on, scroll please. X squared plus y to the fourth equals 81. Okay, so we have to set a template up here. We're going to have a blank squared plus blank to the fourth equals 81. In the first blank where we had an x, we're going to put a negative x. In the second blank, in parentheses, where we had a y, we're going to put a minus y. And then we just simplify, right? The even power square, even square power kills off the negative in the first parentheses. You just get a purple x to the green second power, plus the fourth power above the second term is going to kill off the negative in front of the y. So we're just going to have a purple y raised to the fourth power. This is going to be equal to 81. And that is precisely the original equation. So yes, this one also has origin symmetry. So this two-variable equation, its graph has all three types of symmetry. It has origin, y-axis, and x-axis.